going to try and cover all the main sections of the coordinate geometry topic in this session. We're going to first start with a description of the quadrants of the Cartesian plane. So you can see that in the first quadrant over here, you have all the values of x being positive and the values of y also positive. For example, here I've got the point 1, 1, and x is positive, y is positive. And I've also have the point 3, 4, where x is positive and the y also is positive. In the second quadrant, the x values tend to be negative and the y values are positive. For instance, if I choose this one, it's negative 3, 1, so x is negative, y is positive. In the third quadrant over here, both x and y are negative. For example, if I choose this point here, it's -2, with x and y being negative. In the fourth quadrant, x is positive, but y is negative. For example, if I choose this one here, 4, -2, so the x is positive and the y is negative. So you have 4 quadrants in total, okay? And this is basically the number line where we have all the x values. And then you have a similar line for the y-axis, where when you go up from the 0, you have positive y values. If you go under the 0, you have negative y values. Whereas for x, in the middle it's 0. On the right-hand side, it's positive values of x, and on the left-hand side, negative values of x. So that's how the quadrants function. All right. The next technique I'm going to show you is actually the distance formula. So we have a formula which is called the distance formula, and it helps us to calculate the distance between 2 points, given that we have the 2 coordinates given to us. So we're going to call the 2 coordinates x1, y1, being the first coordinate, and the second coordinate is x2, y2. So if you need to find the distance between these 2 coordinates, I'm going to call the first one a and the second one b. So if you need to find distance of AB, the formula tells you that you need to do the square root of x1 minus x2 to the square plus y1 minus y2 to the square. And the formula is actually derived from the use of the Pythagoras theorem, and I can actually show it to you from the graph in a minute. So how does it work? So let's say our first coordinate a is 1, 1, which we do have on the graph here. So a is 1, 1, and b is here, it's 3, 4. Okay, so if you have these 2 coordinates and you need to find the distance between the two, so this is a and this is b. Let's say you need to find the distance between the two. You can use the formula. So the formula tells you that it's square root of x1 minus x2 to the square, meaning you subtract the x's, then plus y1 minus y2 to the square. So you subtract the y's like this. So you'll see that you end up getting root of -2 to the square plus -3 to the square, which is square root of 4 plus 9, which is root of 13. Okay, so that's the distance. After that, we'll apply the formula. But the formula is basically the Pythagoras theorem, because if you look here, this point is 1, 1, and the other one is 3, 4. So I can actually construct a right angle triangle. Okay, and the 90-degree will be here. So between 1 and 3, I actually have 2 units, and between 1 and 4, I have 3 units, right? And the aim is to find the length of AB, which is the hypotenuse. So if you refer back to the Pythagoras theorem, it tells you that hypotenuse to the square is equal to the opposite to the square plus the adjacent to the square. So here the hypotenuse, which is opposite to the 90-degree, that's AB square. So AB square is equal to 2 square plus 3 square. So AB will be square root of 4 plus 9, which is square root of 13. which is exactly the same answer we got after we applied the distance formula. Okay, so the distance formula and the Pythagoras theorem are actually, they both mean the same thing. So that was the first formula I had to show you. There's another formula which is quite useful in this chapter, and that's the midpoint formula. So I'm just going to erase that and show you how to work out the midpoint. So midpoint means middle. So once again, we're going to use A and B as reference points. So x1, y1, and x2, y2. That's going to be B, and that's going to be A. So if you need to find the midpoint AB, it's equal to x1 plus x2 divided by 2. We're dividing by 2 because we're trying to find the midpoint. Okay, and y1 plus y2 divided by 2, this gives us the mid y value. Now let us see how it works. So I'm going to still use the 2 points we have on the graph here, which are 1, 1 and 3, 4. So if I need to find the midpoint, okay, it's going to be x1 plus x2. So you add the x's and you divide by 2, comma, y1 plus y2. So you add the y values and you divide by 2. So you get 3 plus 1, 4, 4 divided by 2, 2, 4 plus 1, 5 divided by 2, which is 2.5. So the mid value is 2, 2.5. So 2 and then 2.5. You can actually see that it fits the line, and it actually is quite accurate. When you look at our drawing, it does seem to be the midpoint when I try to put it on the graph. 2.5 is exactly in the middle. Okay, so we've done two key formula here. We've looked at the distance formula, and then we've also looked at the midpoint. So these are the two key formula when it comes to working out length, and then trying to locate midpoints, possibly in questions whereby you need to draw triangles, and they give you coordinates, and then they ask you to actually locate the midpoint, and then from the midpoint possibly try to draw other shapes. Okay, so these were the first two ones. The third aspect of the coordinate geometry chapter is actually finding equation of lines. Okay, so we're now going to, okay, let me write on the left hand side here. So equation of lines, that's the next section, equation of line. So if you have 2 points, you can actually find its equation. And the general form of the equation of a line is y is equal to mx plus c, where m is the gradient and c is the y-intercept. Now, what does gradient really tells us? It actually tells us whether a graph is going up. So if a graph is going up like that, it's a positive gradient. If a graph is horizontal, the gradient is 0. If a graph is going down, the gradient is negative. Okay, so the gradient usually gives us an indication of how the line is behaving. All right, so how do we actually work out the equation of a line now? To work out the equation of a line, you will need either 2 coordinates or 1 coordinate and the gradient itself. So let's use our 2 coordinates to define the equation of the line. So the 2 coordinates are 1, 1 and 3, 4. We'll keep the same coordinates for all the questions we'll need to find for this topic. So these are the 2 coordinates, A and B, and let's say the question is find the equation of line AB. But before finding the equation of line AB, which is going to look like the equation written here, y squared mx plus c, we need to have a formula to find the gradient itself. So the gradient m is y2 minus y1 divided by x2 minus x1. So that's the gradient formula if we have two coordinates. So what we can do is we can label our coordinates. So that's x1, y1, the first x coordinate, the first y coordinate. This one is x2, y2. So if we need to find the gradient, it's y2 minus y1. So it's 4 minus 1 divided by x2 minus x1, so 3 minus 1. And that gives me 3 over 2. Okay? So we have the gradient now. What we are going to do next is we're going to actually use that gradient and write the equation of the line from this gradient. So the equation of the line was y is equal to mx plus c. So the gradient is 3 over 2, so it's y is equal to 3 over 2x plus c. You'll see that I've replaced the m, the gradient, by actually the number which we found, which is 3 over 2. Now what's next is we need to find the c. So the c is the y-intercept. To find the c, we actually use one of the coordinates and we replace in the equation we found here. So I'm going to use the 0.11 because it's the easiest one to replace. So this is the x value, this is the y value. So what I'm going to do next is I'm going to replace these two values in the equation. So y is 1, so 1 is equal to 3 over 2 times 1 plus c. So 1 minus 3 over 2 is equal to c. So what is c? 1 can be viewed as 2 over 2. Okay, so we're basically finding 2 over 2 minus 3 over 2, which is minus half. So I now have the c and I have the gradient which we calculated before. So what I do is I rewrite the equation as y is equal to 3 over 2x minus half. And what we can also do is if we don't want to have fractions in our answer, we can multiply the whole equation by 2, so we get 2y is equal to 3x minus 1. Okay, so that was how you can actually find the equation of a line given 2 points. Sometimes they give you the gradient. So if they give you the gradient already, then you don't have this first step. You just replace the m by the gradient they gave you. You have this equation, and then you take one of the, so they won't give you two coordinates, they will give you one coordinate. So you take that one coordinate, you label the x and y value, and you replace, and you get the c. All right? So that was the next section whereby we are finding the equation of a line. Now we're going to explore another section, which is parallel and perpendicular lines. So even before I try to work out the equation of parallel lines, you need to know what they mean. So parallel lines means lines with the same gradient. Okay, so that would be the definition of parallel lines. And then you have perpendicular lines. So for perpendicular lines, I think you can try to visualize them. So there you have two lines which have a 90 degree between them. Okay, so this is line 1, this is line 2, whereas for parallel lines, they have the same gradient, so they have the same direction. So that's line 1, this is line 2. Okay, so when two lines have the same gradient, they are parallel to each other. When two lines are perpendicular, they form a 90 degree between them. Now, for parallel lines, the gradient is the same. What about perpendicular lines? So if two lines are perpendicular, then the gradient of line 1 is actually minus 1 over the gradient of line 2. Okay, that's the relationship between them. Or you could say that gradient of line 1 multiplied by gradient of line 2 gives you minus 1. Okay, if it's a bit confusing, maybe we can actually play with numbers so that you can try to understand how it works out. So let's say line 1 and line 2 are perpendicular. Okay, let's say that's the context. So they look like that. This is line 1, this is line 2. Let's say the gradient of line 1 is 2. Okay, and you need to find the gradient of line 2. So what you need to remember is that if you multiply the gradients, you should get -1, or you can try to remember the first one. So if you need to find the gradient of the other line, so let's say y2, line 2, it's -1 of the gradient of line 1. Okay? Or if you use the second relationship, which is basically the same one, but rewritten in a different way. If I'm multiplying these two, I'm getting -1, because 2 times -1/2 is -1. So if I give you gradient of line 1 is 3, you know the perpendicular line will have -1/3. So it's -1 over the gradient of the first line always. If the gradient is 4, okay, it will be -1/4. So that's how we can actually work out the gradient of the perpendicular line directly. Now let's have a look at how it looks like on the graph. Okay, here we go. So I'm just going to open Desmos and we're going to play around with it a bit. So let's say I have the first line, y is equal to 2x plus 4. Okay, so that's how the line looks like. So the gradient is positive, the gradient is 2, so it's a line going up because the gradient is positive. And 4 is the y-intercept, so it's crossing the y-axis at 4. You can see it clearly here. Okay, so that's how it behaves. Now, if I try to draw a line which is parallel to it, so it should have the same gradient. So I'm going to draw y is equal to 2x so that the gradient is the same. And I'm going to change the y-intercept to 5. So that's the green line now. So you can see that these two lines are parallel because they have the same gradient. Only the y-intercept changed. So for the green line, it's crossing the y-axis at 5. And I can see here that it's crossing at 5. You see, 0, 5. Whereas for the first one, it was crossing at 4. Okay? So that's how parallel lines look like. And in the same way, I can actually create any line I want. So I could write y is equal to 2x, and I just change the y-intercept. So -4. Okay, so positive slope, so it's going up. The y-intercept is -4, so it's crossing the y-axis at -4 here. You see, 0, -4. So that's how parallel lines look like. What about perpendicular lines now? So if the gradient is 2, the gradient of the perpendicular line should be -1/2, which is -1/2, which is -0.5. So it's going to be -0.5 plus the y-intercept can be anything. So I'm going to write it like that. Okay, plus 5. Okay, so it's y is equal to -0.5. Sorry, I missed the x. I just need to correct that. It's -0.5x plus 5. Okay, and you can clearly see if 2 times -1/2 is -1. And now look at the graph. You can see that the two graphs do have the 90-degree between them. Okay, so that's how perpendicular lines are. They form 90-degree where they actually intersect the two lines, and we can clearly see it from the graph here. Okay, so that's how lines are. So you can have parallel lines, you can have perpendicular lines, and sometimes we have vertical lines. So vertical lines will look like this, x equal to 4. Okay, so if a line starts with x equal to something, then you get a vertical line. And we can see here, this line, x equal to 4. It's a vertical line going upwards. And for vertical lines, we don't have a gradient actually, because the line is going up, it's infinite. So if you try to work out the gradient, you'll see that you get divided by 0. And I can show you another kind of line which can exist. That will be a horizontal line. So if I try to draw y is equal to, let's say, 2, then I get this red line here. And this is a horizontal line. So to sum up, you have parallel lines, you have perpendicular lines, you have vertical lines, which was x equal to 4, you have horizontal lines. So these are all the possible lines you could get. And if you're doing IGCSE paper 4, usually they give you different equations and you need to graph those equations. So understanding how these graphs behave will come handy afterwards. All right, so we're just going to go back, double board. Okay, so to sum up, we've looked at distance formula, we've looked at midpoint formula, we've looked at different kind of lines we have, how to draw different lines, we've looked at equation of a line, and the last thing we could actually try would be how to do a quick sketch of a line with our graph paper. So that's the last thing we could actually explore together before we finish this session. So I'm just going to quickly write down the equation of a line. So let's say I have y is equal to 2x plus 4. And I'm going to do a very quick sketch without using using graph paper. So I can see that the gradient is positive, so it's a graph going up. I can easily spot the y-intercept, which is 4. So I know that it's crossing the y-axis at 4. And it's a line going up. So it should look like this. So it's a line going up and then crossing the y-axis at 4. So I know it crosses the y-axis at 4. So I can call it 0, 4, and then I can label this one as y is equal to 2x plus 4. Now, we can see that the graph is going down, it's going to cross the x-axis. We know that on the x-axis, y is always 0. So if I replace y by 0, I get 0 is equal to 2x plus 4, minus 4 is equal to 2x, x will be minus 4 divided by 2, which is minus 2. So I know that it crosses the x-axis at minus 2. So this is how you can actually do a quick sketch given the equation of the line, and reading the equation of the line, looking at the gradient to know it's a positive slope, looking at the y-intercept so that you can locate where it crosses the y-axis, and finding the x-axis by actually equating y to 0. Okay.